So hopefully you've gone on and tried practice 4, combining like terms. But now another way to simplify an expression is to remove the parens, and that's what we're going to use. To simplify these expressions, we're going to use the distributive property. We're going to multiply the first term by 3 and the second term by 3. So we're going to, by removing the parens, we would get 33y plus 18, distributing that 3. Here we're going to distribute a negative 2 times x, negative 4 times x, negative 4 times 0.2y, and negative 4 times negative 3. Negative 4 times x. Now a negative times a positive is negative 0.8 y, because 4 times 0.2 is 0.8. And then a negative times a negative is positive. 4 times 3 is 12. And here for this last example, this is like a take the opposite of, or as if there was a negative 1 on the outside of the parenthesis. So negative of 3x is negative 3x. Negative of 2y is negative 2y. Negative of r is negative r. And negative of a negative is a positive 1. So really we just changed the signs of all the terms that were in the parenthesis. So now you're going to try practice 5. So here we can see, if we want to simplify this expression, the first thing we want to do is use the distributive property to remove the parens and then combine like terms. 4 times 4x is 16x. 4 times negative 6 is negative 24. Bring down the plus, bring down the 20. So I don't have any other x's, so there's nothing to combine the 16x with, so we just bring it down. But now I have negative 24 plus 20. Opposite signs you subtract and keep the sign of the greater. And as I've said before, now you can use your calculator, so I would think you could probably do that mentally. But if you wanted to check, negative 24 plus 20 on your calculator. Here we're going to distribute the negative 3, and here we're going to distribute the negative 1. Negative 21x minus 3. Negative 3 times each term in the parens. Negative of 4x is negative 4x. Negative of negative 2 is positive 2. And now we want to combine like terms. So I draw lines underneath my like terms so that I know that I've covered them, that I've used them. Some people cross it out, but I don't like to do that because then what if you make a mistake? You can't see what's underneath your crossouts. So I use different underlining notation. So here's a negative 21x and a negative 4x. Same signs, you add and keep the sign. When we combine negative 21x and negative 4x, we get negative 25x. And then we've got our constants. Negative 3 and positive 2 is negative 1. So now you can practice with practice 6. This next translation is so important. There's definitely one on the test, and I know there's one on the final as well. So let's take an easier example. If I said to subtract 1 from 5, you would know that's 5 minus 1. Subtract 1 from 5. So even though in the English the 1 came before the 5 in our expression, it's really 5 minus 1 when you convert to an algebraic expression. So addition and multiplication, it wouldn't matter the order that you write the terms down in, but for division and subtraction, it's very important. Order does affect the outcome. So if I want to subtract 7x minus 1, you know what? I want to subtract this whole expression from this whole expression. I want to subtract 7x minus 1. Remember to put that in parens. I want to subtract all of 7x minus 1 from 4x plus 6. You can put this in parens if you want. It's not as important, but this definitely needs to be put in parens. This is how I would express subtracting 7x minus 1, subtracting 7x minus 1 from 4x plus 6. So now when it comes time to solve this, we're going to distribute that negative. 4x, bring down the plus, bring down the 6. Negative of 7x is negative 7x. Negative of negative 1 is positive 1. If I did not have the parens here, I would get a sign error, and I'd never get the right answer. So now let's combine like terms. Let's combine our positive 4x and our negative 7x. That's negative 3x, because 4 minus 7 is negative 3. And now our constants. 6 plus 1 is 7. This is very important. So go ahead and try practice 7, expressing a subtraction problem. So here we're going to end with writing each phrase as an algebraic expression, and they want us to let x represent the unknown number. And if we can, we're going to simplify. So 3 times a number, that's 3x. And see that comma? That means after I multiply by 3, then that is subtracted from 10. The 3x times, or 3 times the number, is subtracted from 10. 3x subtracted from 10. That's how I would represent 3 times the number subtracted from 10. All right, so now I have the sum of a number and 2. Sum means addition. The sum of a number and 2. Once I've got that value, divide that whole expression by 5. See that comma? That means do that operation first, the sum of a number plus 2, and then divide it by 5. Here we have 3 times a number. Well, we know that's 3x. And that's going to be added to, but added to what? Added to the sum of a number and 6. 3 times the number, that's going to be added to, and we want to make sure the sum of the number and 6 is an operation that I do before I do this addition. That's why I have it in parens. So this is like a positive 1 outside. This is going to be 3x plus x plus 6, and combining your like terms, 3x and 1x is 4x. And don't forget your constant, plus 6. And this last one, 7 times what? 7 times the difference. That means subtraction. So I'm going to multiply. What am I going to multiply by 7? The difference of a number and 4. 7 times what? The difference of a number and 4. And to get rid of those parens, we'll distribute that 7. So that would be the simplified way to write that expression. So now you're going to go ahead and try practice 8.